Section 6.3 is anti-differentiation by parts. So this is the rule that we're going to use when we have an integral that has two parts to it that we can't integrate using U substitution, and that we need to split up somehow. So we'll do an example and this will make sense, but get that into your notes. Okay, so here's an example. If we want to evaluate x sine x dx. Now, to try and do a U substitution, if we do U equals x, then du equals dx, I don't take care of that sign. If I say U equals sine x, then du is negative cos x dx, and there's no cos x here, so integration using substitution isn't going to work. But I can split this into two parts. So using our rule, we're going to, for this case, say that u is x and dv is sine x dx. So we'll talk more in class about which part to choose. Generally speaking, if we have a power, we want to make that u, and something else would be our dv. So this whole piece is dv, and this piece is our u. So we put that into our model here. So we're going to use, and let's, I guess they do it underneath. So taking this original separation by parts, we're going to then derivate u, du equals dx. We're going to integrate the dv. So v equals the antiderivative negative cos x. So this is the pattern. We're going to do u times v. So we're going to do u times v minus integral of v du. So this is how that's going to look. Excuse me, I had to sneeze. So we're going to take x times negative cos x, that's our uv, minus the integral of v du. Now since it's minus a negative, they change that to plus. And this is our v du integrated. Okay, so using substitution, again, they're taking uv minus the integral of v du. U is x, v is negative cos x, and then putting the negative sign in front, minus the integral of v negative cos x du, which is dx. And again, bringing that out to make it our plus sign. So now my integral is going to be negative x cos x plus the integral of cosine x. And I think they did that on the slide, but you can see that now that integral is much easier than my original integral. So negative x cos x plus sine x, don't forget your plus c. Let's try another one. So again, that 2x squared is what we want to use for our u. So I'm going to let u equal 2x squared, and dv is e to the x dx. Finding my du and my v, I can now use my model. uv minus the integral of v du. So uv minus the integral of v du. And again, these are the parts that I'm using. So my setup will be, that's my original problem, equals u times v minus the integral of v, my e to the x, du, my 4x dx. Problem is that I still have some work to do here. I'm going to have to do another substitution or another integration by parts. So I'm going to let u equal x this time. I'm working just with this piece. dv is e to the x dx. Doing my substitution, and I'm going to repeat my pattern, uv integral of v du. Don't forget this part here. And I'm going to show this to you another way. I don't really like the way that they write this underneath, but let's keep going. There's my original integral. There's the piece I had from my first parts. This is the piece from my second parts, my negative 4. This is the piece I'm doing by parts again, so that's my uv xex minus the integral of e to the x dx, and that last piece I can integrate. Okay, I'm going to do it over here, and I'm going to show you the way that I write it. I don't really like that they put this underneath, so let's take a look at it, and this way might make more sense to you as well. So over here I'm going to say u is my 2x squared. I didn't give myself enough room. dv is my e to the x. Let's start over. Alright, I'm going to give myself a little more space. Sorry about that, guys. Okay, the integral of 2x squared e to the x dx. I'm going to say let u equal 2x squared and dv equal e to the x dx. My du now is, x squared, 4x dx, and my v is simply e to the x. So I'm going to take these parts and put them in under here. So my integral of 2x squared e to the x dx becomes u times v minus the integral of v du. Okay, I'm going to clean this side up a little bit. 2x squared e to the x minus 4 integral of x e to the x du. And again, off to the side, again I'm tight on space here. My new u is going to be x. My new dv is e to the x dx. I'm off the edge, sorry guys, whoops. Alright, e to the x dx, put dx over there. My du is dx, and my v is simply e to the x. So taking all of this and summing it into here, I'm not sure I made this any easier for you because I'm trying to squish it in. So minus 4 times, this is my new u substitution, u times v. U times v is x e to the x minus the integral of v du, which is just dx now. So 2x squared e to the x minus 4 times x e to the x minus my integral here, which is just e to the x, plus c. Distribute the 4, minus 4x e to the x plus 4 e to the x plus c. So again, what I like to do is just set these pieces off to the side so that our work can go straight down. So this required repeated use of integration by parts. Now there's another way to do this using a tabular setup. If you have to integrate more than once, and you know you're going to have to when you start the problem, and the more you do these, the more you will be able to see whether or not you're going to need repeated integration. So let's look at this using a tabular, and I want to do the same one we just did, where we've got the integral of x squared e to the x dx. Since I have an x squared, I know that I'm going to need to do this more than once. So I'm going to start with a function and its derivatives, and a different function with integration. So this one I am going to derivate, this one I am going to integrate. So I'm going to start with my x squared. My derivatives are 2x, 2, and 0. Once I get to 0, I know that I've done enough. This one's easy because the integral of e to the x is always e to the x. So my tabular is going to be to take these and pair them together with multiplication. 0 doesn't matter. The first one is going to be plus, minus, plus. We go as many times as we want. So x squared times e to the x plus 2x e to the x. Whoops, I'm sorry, that was plus, this is minus. minus 2x e to the x, another plus 2 e to the x plus c. So that's a tabular of integration by parts. Let's try one more. So I'm going to use the integral of x cubed sine x dx. Again, x cubed would be my u, it's the one I'm going to derivate. So I'm going to start with x cubed, and over here I'm going to start with sine x. This is the column I derivate. So 3x squared, 6x, 6, 0. This one I'm going to integrate. The integral of sine x is negative cos x. The integral of negative cos x, negative sine x. The integral of negative sine x, cos x, and one more time to get down to my 0, another sine x. So these are integrating, and these are my derivate. So again, starting with the top left and going down at an angle, those are going to be plus, minus, plus, minus. So my final integral of this is going to be using a positive sign, but x cubed times a negative is going to be a negative. These two are going together. I need another negative sign, so that will make this product a positive. This product uses a plus sign, and they're both pluses, so it stays plus. This is going to be a negative. They're both positive, so it stays a negative. And then my plus c. Okay, and we will do several of these in class. This tabular integration, you do not have to memorize it, but it comes in handy when we have to repeat more than once. All right, let's look at a couple others. Solving an unknown integral. So again, I'm going to do this one without their slide. I'm going to do it the way that I like to do it. So my u is going to be e to the x this time. Now normally e to the x we like for the other one, but you'll see in a minute why we need to do this. Okay, so I'm going to do this. My du now becomes e to the x dx, and my v is going to be negative cos x. So let's come over here. So my integral of e to the x sine x dx is u times v negative cos x. Oh, let's put e to the x in front so it's not after the cos x. Negative e to the x cos x minus the integral of negative cos x. That'll make this a plus. Cos, again, e to the x comes first. Looks better. E to the x cos x dx. Okay, so I've done this once. I know that I'm going to need to do it again. So u equals e to the x, dv equals cos x dx, du is e to the x dx, v is going to be sine x dx. So let's see what we have now. I'm going to recopy what I got the first time using my integration by parts for this. uv, whoops, sorry, no dx there. That was an integrate. Okay, u times v, e to the x sine x, minus the integral of e to the x sine x dx. I appear to be going in circles because I'm right back where I started. So now what I'm going to do, since I started with e to the x sine x dx, I'm going to add the integral of e to the x sine x dx to both sides. Okay, just like good old algebra. So on this side I now have two integrals of e to the x sine x dx. equals my grouping that I got from before, negative e to the x cos x plus e to the x sine x. Okay? If I divide both sides by 2, I have solved for my integral of e to the x sine x dx, negative e to the x cos x plus e to the x sine x over 2. Don't forget to add your plus c at the end. Okay, so that's a tricky one where we look like we're going in circles. We're going to add it to both sides and then simply solve for one of the two. All right, I think this is our last example coming up. So find the integral of ln x. So I'm going to do this with parts. U is just going to be ln x, and dv is simply going to be dx. So I have my two parts, my ln x and my dx. dv is 1 over x dx, v equals x. So the integral of ln x equals u times v, x ln x, minus the integral of x times 1 over x dx. Well, that's just 1. So x ln x minus the integral of 1 dx. We end up with x ln x minus x plus c. This is a good integral to memorize. It comes up frequently enough that if you're good at memorizing things, it's easier, I think, to memorize this than to remember to use parts. It's not as obvious here that integration by parts is going to work. So that's it for our slides. I skipped over their writing to do it my way. This is our quick quiz for sections 6.1 to 6.3. Again, I'm going to go through these videos. You can come back to them later if you would like to use this as a review for our quiz. So I'm just going to go through these slides. And that will be it.